Hi guys, just recording a really quick video just to cover off on some questions about relational algebra, specifically about using the divide operator to actually solve these universal qualification problems. So here we have an example from the trimester 2 exam. It's actually the Comp 589 exam, where we have to get manufacturer names and statuses, so the M name and the M status field for manufacturers who supply all products from our MPJ database. Now recall that most of the past papers have a question on the manufacturer product project database here, and we have our manufacturer table where we have our manufacturers all listed. We have our product table where the products are all listed, and the primary key for that one is the PID, with the primary key from the manufacturer's table being the MID. And then we have our shipments table, which is our MPJ table here, where we link all of those together, and you can see here we have a manufacturer and product ID. So in this query, we want to return the manufacturer names and statuses for manufacturers who have basically supply every part. So they have to have a record in the MPJ table for every single part, every single P record. Now to do this, we actually, in relational algebra, we actually apply the divide operator. Now we covered the divide operator briefly when we went through the relational algebra chapter, and I'll just jump back through. I'll just jump to the document camera here. So you can see here that the division operator, it's actually on page 165 here. Basically, we use the division operator to return records from our first table. So in this particular situation, we're returning all of the records from the SSN underscore PNOS intermediate result, for which there is a record in the for which there is a match to every record in the Smith PNOS table. So if we go and have a look at the table, at the example down here, we can see here that we have, we can see both of those there. So you can see here we have the result from our SSN underscore PNOS table, which is our intermediate result, and it contains basically the employee SSN, so serial numbers, and the project number in this example that they're working on. Then we have the project numbers that employee Smith is working on, and we've actually obtained those earlier on in a query up the top here, where we've found the employee details for Smith, and we've basically joined those onto the works on table to get those project numbers that Smith works on. So here we're going to grab all of the employees that work on all of the projects that Smith works on here, and we can see that Smith works on projects 1 and 2. Now, when we perform this division operation here, so we've got our SSN underscore PNOs table and our Smith PNOs table, this operation will return records, the employee SSN numbers, for which there is a match to every record in the Smith PNOs table. So we can see here that the first record has employee number ending in 789, and it has a project 1. Then we have the employee number ending in 789 with project 2. Now you can see that there's a match to every one of those records, so it's going to be returned in our results set. Then we move on to the next number here, so you can see 644. So 644, if we go through here, we'll find that there's not a match to both of these, so it's not returned. If we go and have a look at the other item returned here, the 453, you can see here that the employee number ending 453 has a corresponding P01 record, and it also has a corresponding P02 record. So it achieves both of those, and it's returned in the results set. So here you can see we're grabbing the SSNs of the employee records that work on every project that Smith works on. Now we can do the exact same thing, follow the exact same process to solve our other query here. So if we jump back to our exam paper here, we can see that we want to perform a similar operation because we want to get manufacturers who supply all products. So we start. So let me shuffle things around here. So we will actually start by filtering our MPJ table so that we only have the MID and the PID. So you just jump back here. So we're going to start by creating an intermediate result called m underscore mpj. So if we have m underscore mpj, now in that particular result, we only really want to return the MID and the PID. So we project using our pi operator to get the MID and the PID, and we want to grab that from our MPJ table. So we can see that this intermediate result is only going to return those two columns for all records in the MPJ table. We haven't done any filtering here. Next, we want to get the PIDs of all of our products. So we'll create another intermediate result called all PID, and we're going to actually just grab the PIDs for all products from the P table. So again, we're going to project to get the PID, and we want to grab that from our P table. So we've created our two intermediate results here. We've got all product IDs, and we've got all of the records from the MPJ table with the MID and the PIDs there. So the next step is to actually perform our division, and we'll do that by creating another intermediate result. So we'll create one called m underscore all underscore p, and we only really want the MID out of this particular expression because we're going to then join that onto the manufacturer's table to get the status and the name of the manufacturer, and we're actually going to perform a division operation. So we're going to take our first result, which is our MPJ, so it has all of our supply records with our manufacturer and our product ID, and we're going to divide that by our all PID result. So if we go through and we close that bracket up, so here we're only going to get records from our m underscore mpj result that have a match to all records in the all PID. So basically we're going to get records, we're going to have MID, PID pairs from this intermediate result here that match, that have corresponding records to all of these records here. And then we're going to project there just to grab the MID. Then to finish up, we have to, of course, get our the particular columns we want, we have to join this intermediate result back to the manufacturer table. We'll do that by projecting first of all, so we only want the m name and the status. And then we have to go and do a join operation. So we're going to join m underscore all underscore p. We're going to join that using a join operation. We're joining on the m underscore all underscore p dot MID table ID. We're going to make that equal the m underscore MID field, and we're going to apply that to the m table there. So you can see here, and that gives us our final result. So we're grabbing the m name and the m status by joining our MIDs, our MID all p MLP table that contains our MID back onto the m relation here, and that will ultimately give us access to these two particular fields because they're sitting in the m table, they're not in the MPJ table. So that just gives you a little bit of an example there of how to apply the division operator. So make sure you go and review that example from the text, and if you have any questions about that one, send them through. There's several questions in the past exams that have a similar approach. For example, if we wanted to modify this query to only return manufacturers grab Sydney manufacturers, we can then put a filter on the bottom one here. Otherwise, if we wanted to get products that reside in products that are blue, for example, we want to find someone who actually supplies all of the blue products, we could put an additional filter in here on the actual the P table here. We can actually filter this for blue products, and that will actually find all of the manufacturers that supply all blue products. So go through and modify those as required, but otherwise this gives you a bit of a template to operate with. So thanks for listening, guys.